Hey calculus class, today we are going to learn about the chain rule. So the chain rule is if you have two functions f and g and they are both differentiable, where you have a function composed with f and g. So basically this is for composite functions, f composed with g. Then the chain rule reads that the derivative of a compositive function is the derivative of the outside in terms of the inner function times the derivative of the inside. So this is the derivative of the outside, derivative of the inside. And you can also rewrite this using Leibniz notation if you let y equal f of u and u equal g of x, and they're both differentiable functions. So the inner function is u, and the outer function is y, rewritten in terms of u. Then you can say that the derivative of y with respect to x is equal to the derivative of y, the outer function, with respect to u, which means in terms of the inner function, times the derivative of u, so the derivative of the inner function, with respect to x. So derivative of the outside times the derivative of the inside. So let's first look at a couple of functions where we are going to identify the outer and the inner function. So if we look at the first one, we should notice that the outer function is the square root of x, and the inner function is x squared minus 1. So go ahead and pause the video and see if you can determine the outer and inner function of the next two. All right, let's see how we did. You should have gotten that the outer function was x to the 1/50th, inner function x cubed plus 2x. For the third one, the outer function e to the x, and the inner function 2x. Now, let's go ahead and actually try the chain rule. And in order to use the chain rule, I best say to use what's called the u substitution method. So you have your example, which in this case is the first one that we just identified, the outer and the inner functions. So your step one is to let u equal the inner function and rewrite the outer function in terms of u. So we already determined that the inner function was x squared minus 1. So that means I have u equaled to the inner function. Now I'm going to take my outer function, which is the square root of x, and rewrite it in terms of u. So f of u equals the square root of u. Now I'm going to go ahead and differentiate both the inner and outer functions. So the derivative of u is going to be 2x. The derivative of f of u, so the derivative of the square root function, is 1 over 2 square root u. Now I'm going to go ahead and multiply the two derivatives together. So I have the derivative of the inside times the derivative of the outside. However, you do need to make sure that your whole derivative is in terms of x. So that's where you're going to replace, in step 4, the u with what we let u be up in step 1, which is the inner function. So this would be considered your final example. You can simplify it, or final answer. You can go ahead and simplify it by canceling out the 2's, and you're left with x over the square root of x squared minus 1. All right, your turn. I want you to go ahead and pause the video and see if you can find the derivative of each using u substitution. All right, let's see how we did. So in this first one, u is x cubed plus 2x. The outer function is going to be u to the 1/50th. I'm going to take the derivative of each. So I have 3x squared plus 2 for u prime. And for f prime, I get 1/50th u times, or to the 149th power. Now I'm going to multiply the two together. So I got the outer times the inner. And then I'm going to replace u with the inner function so that I have 150 times 3x squared plus 2 times x cubed plus 2x to the 149th power. You do not have to simplify. All right, for the second one, you have that the inner function is 2x, so u equals 2x. The outer function is e to the u. Take the derivative of each, so u prime is 2. The derivative of e is just itself. Go ahead and multiply them together. Replace u with the inner function. So my derivative becomes 2e to the 2x. Now with the chain rule, you can also have more than two functions. I like to call it you have an outer function, an inner function, and an inner function. And we typically let the inner function be v. So you first have to identify the inner function. So in order to do that, you kind of look into the function, and you should notice that the inner is the x to the fourth plus 2x. So I'm going to let that be v. My inner function is going to be 3 square root of the inner. So that's going to be my u, but this time I'm going to rewrite it in terms of v. Now my outer function is this stuff to the 5th power, which in this case is u. So my outer function is u to the 5th. Now just like before, you're going to take the derivative of each. So v prime is 4x cubed plus 2. U prime is 3 over 2 square root v, and this is just the square root derivative, and 3 is just a multiple constant. Derivative of u to the 5th is 5u to the 4th. All right, so now I'm going to go ahead and multiply all 3 of the derivatives together to get the following. And yes, of course, I'm going to have to replace everything so it's in terms of x. Before that, I do that, I am going to simplify it a little bit. So I have the 5 times 3, 15u to the 4th, quantity 4x cubed plus 2, all over 2 square root v. Now I'm going to replace v with the inner function, and then u, it will be replaced with the inner function, but I will replace the v in the inner function with the inner function. So I will have the following. And yes, it looks hideous, but that's okay. All right, go ahead and pause the video and see if you can do this one on your own. All right, let's see how we did. You should have gotten that the inner function was x squared. The inner function is 3 to the inner function, so 3 to the v, and the outer function to be 2 to the u. Now I'm going to take the derivative of each. Derivative of x squared is 2x. Now we have the derivative of a exponential with a base other than e, so that means that the derivative is going to be the natural log of the base times the base to whatever power. And then the same thing here, so this will be the natural log of 2 times 2 to the u. I'm going to multiply all 3 derivatives together. See if I can simplify anything. I cannot. And replace. So it's all in terms of x. So I just brought the natural log of 3 and the natural log of 2 out together. And I replaced the v with x squared and the u with 3 to the v, which is 3 to the inner. Now you can also do the product and quotient rules combined with the chain rule. So sometimes while you're doing the chain rule, you have to do the product or quotient rule, or you'll be doing the product or quotient rule and have to use the chain rule. So in example 3 here, we have 2 functions that multiply together. So we should see that my first function is 5x and my second function is e to the negative x. So there's my f of x and g of x for the product rule. All right, so as we can see, we have 2 functions multiplying together. So that means that I want to apply the product rule first. So I'm going to take the derivative of the first times the second plus the first times the derivative of the second. So when you need g prime, you will have to apply the chain rule right here. Not for f prime because it's just 5x. So let's go ahead and find g prime now to get it out of the way. So my inner function is negative x. So my outer function is e to the u. Take the derivative of both. So u prime is negative 1 and f prime is e to the u. Multiply them together and replace u with whatever my inner function was, which in this case is negative x. So now I have g prime. So now I can go ahead and find the derivative of this function using the product rule. So I have the derivative of the first, which is 5, times the second, plus the first times the derivative of the second. And notice here, g prime is the derivative that I found down here with the chain rule. And you can go ahead and simplify if you like. I get the following. And you can pull out a 5, you can pull out an e to the negative x if you like. And if you do, you should get 5e to the negative x times 1 minus x. You do not have to simplify it this far unless it's a multiple choice question. All right, example 4. Here's a challenge for you. I challenge you to press pause and see if you can do this all by yourself before you watch me give you the answer. All right, let's see how we did on our challenge. So notice here I have two functions dividing, so I will have to apply the quotient rule first. When I find the derivative of the top, I will have to use the chain rule. When I find the derivative of the bottom, I will also have to use the chain rule. So after doing all of that, you should get the following. And let me explain this whole thing. So the derivative of the top, so my inner function is x minus 1. So the derivative of x minus 1 is just 1. So it's not really going to affect anything. Times the derivative of the outer, which is u to the fourth. So there's my 4 times my inner to the third power. So there's the derivative of the top times the bottom minus, right here, the x minus 1 to the fourth, that is the top. So the derivative of the bottom, so the derivative of the inner function, x squared plus 2x, is 2x plus 2, times the derivative of the outer, so u to the fifth power, which would give me 5, u, which is the inner function, to the fourth power, all over the bottom squared. So in this case, x squared plus 2x to the 10th power. Now I'm going to simplify. So in order to simplify, you should notice that we have an x minus 1 cubed in each term, and an x squared plus 2x to the fourth in each term. So I factored those out. So I'm left with 4 times x squared plus 2x minus 5 times x minus 1 times 2x plus 2, all over the denominator squared. Now I'm going to go ahead and distribute through inside these brackets so I can simplify that. And we can also notice that we have x squared plus 2x on the bottom and top. We have 4 of them on top, 10 of them on the bottom, so we can cancel out 4 of them. I can also combine like terms, so now we have x minus 1 cubed times negative 6x squared plus 8x plus 10, all over x squared plus 2x to the 6th power. And if you wanted to, you could factor out a negative 2 in this trinomial. You do not have to. It's not a big deal. All right, another challenge, example 5. Let's see if you can do this one on your own. Go ahead and pause. Welcome back. Let's see how we did. So here, this one's going to be different. I'm going to have to apply the chain rule first, and while I'm applying the chain rule, you'll have to notice that my inner function is a quotient. So I will apply the quotient rule when I find the derivative of my inner function. After doing the chain rule, you're going to get the following, and I'll explain each piece. So we have the derivative of the outer, which is just u to the third power. So that means the derivative of u to the third power is 3u squared. So there's the outer derivative. Now, to do the derivative of the inside, I am applying the quotient rule. The derivative of the top, which is 1, times the bottom, minus the derivative of the bottom, which is also 1, times the top, all over the bottom squared. Now I can go ahead and simplify to get the following, and I can cancel out the y's, combine like terms, to get the following. Now I can use the exponent property where I can say I have y to the y minus 6 squared over y plus 7 squared, and also at the same time do 3 times 13 to get the following. And then I can have, I have y plus 7 squared on the bottom twice, so that means I actually have y plus 7 to the 4th power. And you are done. All right, here's another one. Let's see if you guys can do this one. All right, so let's see how we did. For this one, you have to apply the quotient rule first to get the following. So the derivative of the top, you're gonna have to use the chain rule here. So the derivative of the inner is 2x. So the derivative of 2x is 2. And times the derivative of the outer, which is e to the u. So the derivative of e is just e, so it's e to the inner, times the bottom, minus the top, times the derivative of the bottom. So derivative of the inner, so the inner is 2 minus x squared. The derivative of that is negative 2x, times the derivative of the outer, which is the square root function. So 1 over 2 square root of u, which is your inner function, all over the denominator squared. Now to simplify, I can cancel out these 2's. The negatives become a positive. And I am left on this side of the numerator with x e to the 2x all over a square root of 2 minus x squared. On the denominator, the square and the square root cancel. Now to continue simplifying, I'm going to want to find a common denominator on the top. So this term needs the square root of 2 minus x squared. So I multiplied that to this side, which cancels out the square root. And next I can go ahead and bring down that denominator to join the 2 minus x squared to get the following. Next, I can go ahead and pull out the e to the 2x that they both have in common and distribute the 2 through inside the brackets to get the following. And if you wanted to, you could simplify this even more. You can make the denominator 2 minus x squared to the 3/2 if you wanted to, but you do not. So you can stop right here. I hope you enjoyed the chain rule. Don't worry, we will practice lots with the chain rule. It just takes time. All right, I will see you in class tomorrow. Have a good night.